the first thing I'm going to do for every single one of these questions, and it's going to feel a little bit redundant, but I'm going to do it anyway, is I am going to, before I start working the question, I'm going to describe the structure of it, of the limit problem. Because we have different strategies for limits with different structures. Okay? Now, really important, folks, what did I just draw? An arrow pointing at the problem. I did not write an equal sign. I'm not in the middle of my math work here. This is just a casual conversation where I'm going to classify this limit problem before I get going. If I were to evaluate the numerator at 3, what would the numerator be in this problem?
0.
Would it? 9 minus 18 minus 9. Folks, I need you to change this. I'm so sorry. Change this to a plus 9 here. That's an error right off the bat.
That makes a lot more sense.
Okay. Bill, there's a copy right up there on that table.
18 over 0.
Ah, what's that?
18 over 0.
Well, let's see. Now that I've fixed this, if you plugged it in 3, you'd get 9 plus 9 is 18, minus another 18. So this has what we call the indeterminate form, 0 over 0. Now, I'm going to do this every single time today, and it's going to feel exhausting, but it's to drive home the point that most problems you encounter in this class have the indeterminate form 0 over 0. Okay? So, how do we, so, folks, it has the indeterminate form 0 over 0. Can I immediately do direct substitution on this problem?
No.
No. So my strategy is to do some sort of rearranging of this problem and hopefully then give an equivalent statement that will let me do direct substitution on it. So here we go. What do you think our strategy should be? What should we try for this problem?
Factoring?
We should try factoring it. So one of our tools is just to try factoring the problem and see if we can cancel that factors. Will that trick always work? No. Even if it looks like you could factor it, that doesn't guarantee that trick's going to work. Okay? But let's see what we can do here. If I rewrite the problem, we've got the limit as x is approaching 3 of x minus 3 times x minus 3 all over x minus 3 times x plus 3. Any questions on how I factored that?
No.
I can now rewrite this as the limit as x approaches 3, and I can write that as x minus 3 all over x plus 3. Now, what was the domain of this expression before I did the canceling?
All real numbers except 3 and negative 3.
All real numbers except for 3 and negative 3, and we said, oh, look, our limit value is 3. I cannot do direct substitution on this. What's the domain of this function that agrees with this other function? What's its domain? All real numbers except for
Negative 3.
negative 3. What's my limit value?
3.
3. Can I do direct substitution on this?
Yes.
Yes, I can. So we do so. Now, when you do direct substitution, you are evaluating the limit. We no longer write the limit operation. So now we write 3 minus 3 all over 3 plus 3, which gives me 0 over 6, or 0. How are we doing, folks?
Good so far.
Let's look at letter B here. I've got to zoom in on these so I can write a little smaller. Let's look at letter B here. If I were to classify this problem, folks, am I writing? Folks, this is very important. If you write equals 0 over 0, I have to deduct a lot of points from you. Does everyone see that this is not what I'm writing? I am not writing equals 0 over 0. You may never write that in line with your math work in this class. Instead, what I'm doing is I'm pointing at it, and I'm just describing the structure of it. If I were to let the numerator be 3, it would come out to be 0. And if I were to let the denominator be 3, it would also come out to be 0. So this tells me we've got an indeterminate form. Can you guess what the answer is going to be when you have an indeterminate form?
No.
Think about that word, indeterminate. Think about that word, indeterminate. You cannot determine it. The answer might be 0. The answer might be infinity. The answer maybe does not exist. The answer may be 27. You have no idea at this point how everything's going to shake out. All right, let's do it. So we'll write this as the limit. As x approaches 3, I'll go ahead and put into factor form. Is this a little redundant? Yes.
X plus 3. Wait, no, the top one should be
Oh,
x.
thank you.
Bottom
X
three.
minus 3 squared.
Great.
Okay. In this case, I can factor out the thing that's giving me trouble. Or I can factor out one of those factors that's giving me trouble, and I'm left with this. Now, what was the domain of the original expression? It was all real numbers except for
3 and negative.
no,
Negative 3, sorry.
all real numbers except for just 3, right? What's the domain of this? All real numbers except for
3.
which is still my limiting value. But look at the structure of the problem is no longer 0 over 0. Right? Again, folks, notice what I'm not writing. I'm not about to write equals 6 over 0. If I wrote that, I would be wrong. Okay? All I'm doing is pointing at this problem here. Oops. All I'm doing is pointing at this problem here and saying that it looks like 6 over 0. I'm just telling you what it looks like. I'm not saying that's what it equals. So this limit, in fact, does not exist.
If we put equals does not exist, would that be
I would prefer you just write limit doesn't exist, or you write the original question, put does not exist, or something like that. But if you put equals does not exist, I'm not going to mark the run. Now, if I had asked you to do the limit as x approaches 3 from the right of x plus 3 over x minus 3, what would this limit be?
positive?
I want everyone to write down something, talk in your group. What would this limit be?
I think a really, really small number.
Yeah, but it'd still be positive.
Yeah,
So
which would
we're-
make it
Yeah.
positive.
Yeah.
Yeah.
But blank. Or the critical options would be, yeah.
Now, folks, really important. Look at what I wrote is my math work here. I wrote that the limit equals infinity. Did I put equals 6 over a small positive number?
No.
Well, you.
I pointed at it with an arrow to describe it to myself. But this is the work. There's no real work to show for this. Okay? We will do one problem in this class where we actually prove that the limit is infinity, and that's the only correct work you could ever show for this problem, and I don't want to make you do that for every one of these problems. So there's no work to show, and I don't want you putting something wrong. Okay? All right. Also, if we had done the limit as x approaches 3 from the left of x plus 3 all over x minus 3, this would be what? Negative infinity. Now, folks, I know you've got to have questions, because I know that half my students miss this problem. So I know you've got to have questions. I need you to say, why? Talk to, I need a question to come from you, or I can't help you.
So does it not exist because infinity and negative infinity don't agree with each other?
So there's a little bit more going on, but that's good enough. One way you could say it is the right-hand limit came out to be infinity, the left-hand limit came out to be negative infinity, and so that's why I concluded that this particular limit in green, that I've written in green, the original question, doesn't exist, because the two limits don't agree. Okay. There's a little bit more going on that I don't want to get into right now. That's a good enough explanation. Does anyone have any questions as to why this is minus infinity? My numerator in this problem, the numerator is getting closer and closer to 6, and the denominator is getting closer and closer to a small negative number. Why don't I just write 0, folks? Why don't I just write 0?
Because it doesn't reach zero?
I'm sorry?
Because it doesn't reach zero?
It doesn't reach 0, that's true. It also doesn't ever actually reach 6 either. It just keeps getting closer and closer to 6. Right? Folks, what's the sign on a neighbor just to the right of 6? What's the sign on it? Just to the right of 6. It's positive. What's the sign on a neighbor just to the left of 6? Positive. If 6 looks to its left or its right, the neighbors on either side are positive. If you picked a negative number, like negative 20, and you look to negative 20's left or right, its neighbors on either side are both negative. If 0 looks to its left, if 0 looks to its your left, over here, if 0 looks over here, its neighbors are negative. And if 0 looks over here, its neighbors are positive. 0 is, that's the whole issue here, which makes it either plus infinity or minus infinity. So that's why it wasn't enough to say the denominator was approaching 0. I wanted to say the denominator was approaching a small negative number. And in your calculator, if you took in your calculator 6 divided by negative 0.00032, which is a small negative number, you get a large negative number as that output. How are we doing? Okay. Folks, did these two problems look alike?
No. Well,
Yeah.
I think so. I think they look very. Would you have guessed from the get-go that A and B were going to have very completely different answers?
yes.
No.
I couldn't.
No.
I had forgotten until I was halfway through the problem what the answer was going to be. I wrote this yesterday. I'd forgotten. I couldn't have guessed. This had the indeterminate form 0 over 0, and I got an answer, 0. This had the indeterminate form 0 over 0, and the limit ended up not existing. This is my answer to this question. I don't think you can look at some of these problems and immediately guess what the answer is going to be. We've got to break it down. All right. the expression inside the absolute value would always have a positive sign. Do you see that? We take a number like 2.9 for x, and if I did 3 minus 2.9, I get a small but positive number. Folks, how do you take the absolute value of a positive number?
You leave it alone.
You leave it alone. Okay? So this is the limit, and then here I had a student once say, oh, to show that I left it alone, I'll put parentheses around it. You don't have to do that, but I kind of like that idea. So this gives me the limit as x approaches 3 from the left of 1, which equals 1. And so the limit proper, I'm sorry I'm out of room here, folks. The answer is that the limit does not exist because the left-hand limit and the right-hand limit disagree. Okay? Now, folks, please, sometimes I ask you to do the whole question. Sometimes I choose just one direction for you, and I just want you to look at that one direction. Yeah?
So if you give us the limit proper on like a test in that example, you'd want us to look at left.
You'd have to do both and show that you would have, I mean, I know you know that they're going to be different because you've worked a few of these problems, but you have to show me the left-hand limit and the right-hand limit disagree before you can say the limit doesn't exist.
Yep.
Folks, I have students not like this problem. I love this problem. The limit as x approaches 3 of 1/3 minus 1 over x divided by 3 minus x. Folks, can I do direct substitution on this problem? No, just like before, this has the indeterminate form. 0 over 0. More work must be done. When I describe this problem I've never liked this term. In an algebra textbook, it would call this thing a complex fraction. I really don't like using the word complex. That means something different in different situations. But what they mean is that you've got fractions inside of fractions. Everyone see that? Okay. And so we've got the major bar, the major fraction bar. Okay. And in the numerator of that major fraction, we have fractions. What I'd like to do, if I can, let's call it the baby fractions, for lack of a good term. I would like to get rid of the baby fractions there. How do you get rid of fractions? By multiplying by the
Least
No.
common denominator.
Least common denominator.
common denominator, the least common denominator. If you multiply by the reciprocal, you get the number 1, true, but that may not be what you want to have, so good guess. But the problem with that is that would give you, if you multiply by the reciprocal, I don't even know what it would be because you'd have to combine them. So I don't want to go there. Okay? By the way, folks, I do not want you to muscle your way through this. You could get a common denominator and then to combine these into a single fraction. That is a legal way of getting there. You will get the right answer, but I need you to work on these skills because I know what else is coming down the road. A lot of times in these limit questions, what I'm really doing is making you practice algebra steps that you will need down the road. Okay? So, the common denominator of this baby fractions is 3x. Does everyone agree? And notice if I multiply 3x to the first fraction, I'll clear out the fractions. And if I multiply 3x to the second fraction, I would clear out the fractions. Does everyone see what I mean by clear out the fractions? If somebody said, take 1/3 minus 1 over x and multiply it by 3x, if somebody said to do that, you would distribute this to both terms. And if you did so, you would get 1/3 and 1 over x times 3x times 3x. Everyone see that? I need a thumbs up, thumbs down, because this is just going to keep building, so I got to know, are we okay with that? Anyone not okay with that step? Okay. So, notice that if you wanted to, you could think of this as being over 1 and over 1. If you really don't see it right away, if you wanted to, you could do that. I don't like doing that. Okay. But now at this point, notice that the factors of 3 cancel here, and the factors of x cancel here, and so I'm just left with x minus 3 when I do that. Okay? Folks, I think if you don't, if this looks strange to you, please rework this problem 50 times. Because I need you to be able to do this in your head. I'm not going to lie. I don't want you to write out this middle step here. I want you to go from here to here in one step. Do you see how you could do it? You think of 3x being multiplied to a third, what cancels? The 3's. You're left with x. Multiply 3x times 1 over x, what cancels? You're left with 3. Okay? You need to get comfortable with that because we're going to be doing that on the fly, in the middle of a problem. Okay? Happy to go through it now? Okay. All right. So we get this expression here. Why? Because I can't just multiply the numerator by the common denominator, right? I have to multiply, because I can only ever multiply by what?
1.
By 1. Okay. So when I do this, this leaves me with the limit as x approaches 3 of 3 minus x all over 3 minus x times 3x.
Wait,
Isn't it
x minus 3?
Ooh, great catch. Good catch. Good catch, folks. X minus 3. Now, why didn't I do direct substitution right from the get-go? Because I had an indeterminate form. Can I do direct substitution now? No, but do you see that I'm a step closer to being able to cancel out that problematic factor? Yeah. Isabel?
Yeah.
Yeah.
Why can't you just multiply the 1/3?
She's saying to multiply by 1 over 3 minus x.
Well, that would just make your denominators more messy,
Okay.
right?
Yeah.
Like if I took 1/3 minus 1 over x times 1 over 3x, that would make this denominator 1 over 9x, and that would make this denominator 1 over 3x squared. Right? And we've just made it messier. What you could do is you could try to get a common denominator inside here and add the fractions, but I'm discouraging students from going that way. I'm not saying you can't. I'm discouraging it. Yeah. So folks, one more step. We see this factor step all the time in this class. Are these two factors the same?
Yes.
No.
They're not exactly the same, but
you
they're
can
close.
rearrange it.
And if I were to factor a negative out of the numerator, if I were to factor a negative out, I get minus x plus 3. Does everyone see that?
Yeah.
Okay. All over 3 minus x times 3x. And now, these are the same factor. Does anyone need me to rewrite? Because you see that if you just reorder it, those cancel.
Wait. Yes.
Folks, I know there's some people being quiet, not feeling like they got the right to speak out. Folks, you paid good money to be here today. Speak out when you got a question. Yeah?
You can factor out a negative from just the numerator, but don't have to do it for the denominator as well?
Well, so notice I didn't divide out that negative. I just factored it out.
Oh, yeah.
Right? I didn't
You're
cancel
like-
out the
yeah.
negative.
I got you, okay, thank you.
Yep.
So it's just a little bit.
Nice.
You didn't actually change the expression.
I'll take myself up there. That's gonna be hard for me to spot. That's gonna, yeah.
Yep, shoot.
We've got a little bit of time remaining, so I want to do a couple more problems. Folks, all these problems on here are fair game problems. I'm going to jump down. I want to talk about this. These were the section 2.4 problems. Notice I'm still using 3 in them. Okay? These were the section 2.4 problems. Okay? This answer, this is all I need you to write. Now please, folks, I dislike it if a student writes this. It's not wrong, it's nothing, but I dislike it if a student goes ahead and just writes, okay? Because I'm trying to get you to speak in complete math sentences, and all you did was like give the last part of a sentence, right? Okay? So I would prefer you to write this whole thing. The limit as x approaches 3 from the right of 1 over 3 minus x equals minus infinity, and I dislike it if you just put that up there. Okay? How are we doing with this? Now, that's all you have to write for this problem. Okay? But let's describe it a little bit. What I do think would be a good thing to do for this problem is to label it as having the not the indeterminate form, the form, what? What's that?
1 over 0.
This has the form 1 over 0. And then specifically, we say that the answer is minus infinity. How come? Because the numerator was approaching 1 over a small what sign number, folks?
Negative.
Small negative number. What's 1 over a small negative number? It becomes arbitrarily large. So we call that negative, arbitrarily large and negative. So we call that negative infinity. Folks, can you just go off the sign right here as far as coming up with your answer? No. Does the sign right here matter? Yes, but that's not enough. It's how this interacts with this. So if we look at this one, we've got the limit as x approaches 3 from the left of 1 over 3 minus x. What is that, folks?
Infinity, positive infinity.
Positive infinity. Is everyone okay with that? I have no extra explanation to give, but I can go through it again if you'd like. Okay. So this limit does not exist. Okay. Now, if I only asked you part C, what do you need to do? You'd have to show the left-hand limit and the right-hand limit, show that they're not equal, and then you can conclude that the limit doesn't exist. But because you've already done that in part A and part B, I'm not going to make you repeat your work. Does everyone understand what I just said? Should I say it again?
Yes.
Yes. If I gave you a test question and I just asked this, you would need to show the limit from the right is negative infinity. You would need to show the limit from the left is positive infinity, and then you could conclude that the limit doesn't exist. I'm not going to make you write all this work again in this sequence of 3 problems because it would be repeating some of it. But if it was a standalone question, you have to show the left and the right-hand limit disagree. How about this one here, folks? Yeah.
Oh, sorry, no, I'm using my hands.
Oh, that's okay.
Think.
I got positive infinity.
I get positive infinity as well.
Because of that squared.
How come?
Because of that squared.
Because the numerator is approaching 1, and it's all over a small what? What's the sign? Now, when I do 3 from the right, if I do 3 minus 3 from the right, that's a small negative number, but then what do I do to it?
Squared.
Square it. When you square something that's negative, it becomes
Positive.
positive. So this is over a small positive number. Notice that when we didn't have the square, we got minus infinity. Can you just make general assumptions? I discourage you from making general assumptions about these problems. Work each one as its own. Okay? The other thing is I forgot to do this. On all of these have had the form 1 over 0. They have not had the indeterminate form 0 over 0. That's why there's no work required in doing these problems. These are the section 2.4 problems. Likewise, let me just point out that this limit is equal to infinity. Why can I conclude that for this one?
Because both limits.
If I approach this from the right, I get infinity. We just showed that. And if I approach it from the left, I get infinity. Okay? So you would have to, that's letter F. To get there, you'd have to do E as well. And I skipped over E. All right. That's all. That's what happens when you just